This presentation will talk about electromagnets and how they work with motors and the generation of electricity. Magnets is an object that's made of substance usually containing a magnetic material. Iron is a pretty common one. I think nickel can be used as well to make a magnetic object that will be able to be magnetized. And when these objects are magnetized, they demonstrate a magnetic field. You can, if you like, get a bar magnet and put a piece of something like tissue paper over the top, sprinkle iron filings, and you'll actually get a pattern like the one below here, where you've got the red magnet and then the iron filings, some sticking to it and others in patterns on the paper around it. And that's because this is the way the magnetic fields work. And on the right hand side you can see a magnet with the north and south poles that are marked, and then you can see these lines, which are the actual magnetic fields or lines of magnetic force that are generated by this magnet. And this is a permanent magnet, so it remains like this. Electromagnets are made by getting a piece of wire and coiling it, usually around another piece of metal. And here in the one below we've got an electromagnet, and it's wrapped around a piece of metal, probably a piece of iron. And you can see as the electricity runs through it, it becomes a magnet with a north and south pole. Now, each time the electricity is sent in a different direction, and that can be seen by the red arrows, you'll see that the north and south pole change. Now, this affects the permanent magnet, which is the other block with the N and S written on it. And as the poles change on the electromagnet, the permanent magnet is either repelled or attracted, just like the bar magnets that we had a play with class in, and you saw how different poles attract and like poles repel. By using this property of like poles repel and different poles attract, we can actually get a coil of wire hooked up to a battery and put it in a magnetic field and make it turn around. And here, if you have a look below, you'll see this coil of wire which is turning in the magnetic field between the north and the south permanent magnets. And if you look at the connection to the battery, you'll see a yellow and an orange sort of half circle shape at the bottom of each wire. Now, you'll notice that these turn around and they change connections as they turn around, which means it changes the direction in which the electricity is flowing, and it will change the polarity or the north and south pole of that electromagnet, which again either repels it from one or attracts it to the other. And so eventually what happens is, with this constant changing of repelling and attracting, the loop turns in that magnetic field. And this is the basic principle of a motor. Now, electric motors use large lengths of wire woven into coils in the center of the motor, and the picture at the bottom here can show you a very powerful motor with lots and lots of wire wrapped around in coils to make that very, very strong electromagnet and powerful electromagnet in the middle of the motor. And of course, you've got some magnetic material on the outside which is going to either repel or attract the areas of the electromagnet and make the motor spin on that axle that it's on. In a similar sort of principle, we can get a coil of wire connected up to, in this case, a voltmeter and also a light or a lamp, and you can see that as that magnet is dragged through the loop of wire, it generates electricity. It causes an electric current in the loop, and that's because of the effect of the magnetic field on the loop of wire. And the more you loop it, the greater effect. So the more loops are in that coil, the greater the effect that the magnet will have on it. This is the same principle that is used to generate electricity. I mean, obviously this is a little example, but in terms of generation, here is a large turbine generator. Now this is driven by steam, so steam rushes into where the steam entry is on the left hand side, and then goes into turbine blades, which of course the steam rushing in there pushes the blades around and it turns them round, and as it does so, it turns the rest of the turbine, which in the second compartment has coiled wire in a magnetic field. And as we've seen before, if you move coiled wire in a magnetic field, you'll get generation of electricity. So by using steam that is produced by burning coal or gas, or even by a nuclear power plant, that steam is used then to turn the turbine blades, which in turn turn the coiled wire cylinder in the magnetic field, and that generates electricity. So the Latrobe Valley and also other steam-based generators generate electricity like this. Also, instead of steam, if we didn't have steam but rushing water coming through there, it has the same effect. And hydroelectric schemes allow water to turn these turbine type blades, and that of course turns the second compartment, which is the coiled wire in the cylinder, in the magnetic field, and that generates electricity. The big advantage of course with the hydroelectric scheme is there's no pollution or no gases produced, particularly those that might be the problems of causing climate change. So the hydroelectric have an advantage of this. Oh, by the way, the wind generators are basically the same principle. Instead of the turbine blades, of course, you've got the big blades of the propeller that are turned by wind, and again that turns the cylinder, which generates electricity. So all of these electrical generation, with the exception of solar, are all based around this sort of model.